Welcome back, Mystic Wonder fans. Today, I'm going to be talking about a little neurophilosophy, bringing in my neuroscience background. So, just a disclaimer here. This episode, the philosophy will get explicit. So, if you don't like having your worldview challenged or changed, this might not be the video for you. Just a little disclaimer there. Might not be for those weak of heart. Alright. So this is essentially it. This is a truth of neuroscience. Untold truth. And it goes like this. This is your brain. This right here is your brain. You are looking at your brain. What you are seeing, to be specific, is your brain. This right here is your visual cortex. The activity of your visual cortex. Now, it's not exactly that simple. You know, there are higher order processing. There's secondary association areas, visual association areas, the ventral stream, the dorsal stream, the parietal lobes involved, temporal lobe. But just to simplify things, just imagine it as what you're seeing right here is the activity of your visual cortex. Is your visual cortex the very neurons? There is a map in the visual cortex. So what happens is light is out in the world, right? Light hits objects in the world, goes into your retina, hits your retina, goes in your eye, hits the retina, goes through the optic nerve, crosses over, goes through the optic tract, then there's a lateral geniculate nucleus, that's the relay station in the thalamus, there's an optic radiation. Essentially, it all ends up at the visual cortex at the back of the brain. That's where all the information is processed, decoded. That is what we call a retinotopic map, because there's a one-to-one correspondence between spots on the retina, spots in the visual cortex. So you have this map of the world, and that's where the image is created. That's how we have dreams, right? I know this sounds baffling, but think about it. It should make sense when you think about it. This is how we have dreams. Every night you are sitting, or not sitting, laying down. Maybe you sleep sitting. But there's no real objects there. There's no light hitting your retina. Yet you see and feel a whole world of things. You can see tables and chairs and trees and mountains and rocks. And they feel solid. Try it out. Go in a dream. Touch a rock. There it is. There's no real rock there. It's in your brain. So at some level you must have known this. How else would dreams work? At least now that you think of it, it should make sense. So one way to think of it is that brain tissue kind of dreams up your experience of the world. And yeah, it's a little bit counterintuitive, but there's no alternative. Like, what is a dream then? It doesn't make sense. I mean, this is the findings of neuroscience. This is just science itself. Do you believe in science? You look in the brain, you can stimulate this region directly. People will see things. It's pretty simple truth. It's just bizarre, which is why it's not talked about that much. So just take a moment to take this in. You're looking at brain stuff. That's right. It's pretty baffling, I think. So this makes the hard problem of consciousness a bit more interesting, doesn't it? The problem of what is the gap between neurons firing and subjective experiences? If vision is obviously a subjective experience, it's part of your stream of experience. It's part of the content of your awareness. So this is identical to neurons firing, or at least something in the brain. It could be smaller than the level of neurons. People tend to think of neurons as either a 1 or a 0, it's firing or it's not, but it's way more complicated than that. The neuron itself has so much complexity in it. It's as complex pretty much as the whole brain put together if you think of neurons as ones and zeros. The amount of things going inside a neuron. So it could be something at the fundamental quantum level, some kind of molecular thing within the neurons. But, for the sake of speaking, we'll just say this is neurons firing. That's what visual activity is. And it's not just vision. What you're hearing your brain too. That's your auditory cortex. Smell, taste, touch. You have sensory processing in your brain for each of these senses. So you touch something, there's a somatotopic map, a one-to-one correspondence between regions of the skin where it gets stimulated, the nerve is activated, it travels up into the brain, and there's a little strip right in the parietal lobe. That's somatosensory. They have a little homunculus, so different areas that have different sensitivities, like the lips are huge, the fingertips are huge, your back right here, tiny, but so there's a homunculus, and that is your experience of your body. So every sense is your brain when you're actually experiencing it. Now, we've known this for a while. This is called the identity theory of mind. It's a pretty standard theory as far as materialism goes. As a caveat, it's not limited to materialism because, what is the brain itself? Is it material? You could argue it's made of consciousness. But besides the point is that the brain has been objectively, by science, empirically identified to be identical to our subjective experiences, at least sensations. And what about abstract things like thoughts? Well, that's just the frontal lobe. So people think of their brain, they think of their thoughts and emotions, oh, that's my brain. Well, sensations too. This right here is your brain. So behind this, right here in your visual field, is your skull. Your skull's behind this. Isn't that wild? I think it's pretty wild. This goes back to the 1950s when philosophy first fleshed it out, the identity theory of mind. The first guy was U.T. Place. His paper is Consciousness of Brain Process, and then later elaborated on by J.J.C. Smart, who's one of the most popular, well-known identity theorists. His paper is called Sensations and Brain Processes. And he basically said, we can't say a priori, like on logical grounds, that there's no way sensations are brain processes. There's no logical argument for that. Yeah, it may be a little counterintuitive, but it's solid. And so I'm just taking identity theory to its logical conclusion. This is your brain. So, we even knew from the time of Descartes with his dream thought experiment. Could this all be a dream? This isn't the external world itself. These are just perceptions of the world. So, it took until neuroscience really developed to see things clearly, though. To, develop actual brain imaging, MRI, PET scans, CT scans, so that people can report their actual experience, and then they'll just look in the brain, oh, here it is. This part of the brain is active. That's the experience. And you can simulate that part of the brain and make people see things. That's what a dream is, basically. The activity in the visual cortex is very, very similar to when you're awake. It's just that it's not coming from the eyes. All the sensory information is not coming from the external world. It's generated within. But still, that brain, processing generates the experience, or rather, is the experience. So things that appear a certain way aren't always reality. Like, what is lightning? Lightning, oh, there's a flash and a sound. That's what it looks like. But science has said, well, lightning is electrical discharge. We know all about the science of lightning. That's what it is. I've identified it with this electrical discharge phenomenon. And that's lightning. So that's the same thing that's going on here. Oh, red and blue and warm and any subjective experience, any qualia, we can say, well, that's been identified with a certain brain process. So that's identity theory in a nutshell. Another objection is like, oh, well, we mean different things by the words for sensations rather than the words for brain processes. But that argument fails too. We mean different things by the evening star and the morning star. It's the same thing. It's the planet Venus. So a word could have different senses. That doesn't mean it's not referring to the same thing. And then, one way out is you could say, well, all we know for sure is that brain processes are correlated with subjective experiences, with sensations. So it could be that there's a brain process and then that's in parallel to the sensation or causing the sensation. Then you end up with dualism, so paradoxical dualism. And that doesn't make sense because energy can't be created or destroyed. The energy can't just go from your brain. The energy disappears, turns into a mental sensation, and then the energy reappears in your brain as something else. That violates the laws of physics, the law of the conservation of matter and energy. So why do we need some outlandish theory like that? We just need to accept that this is your brain, that the brain processes themselves are the sensations or any subjective experience. Because dualism is just paradoxes. Like how do mental and physical were totally different substances? How would they interact? If there's a way they interact, then there's some underlying unity of both. So philosophers hate dualism because there's just so many paradoxes like that. But anyways, this is not just some radical theory and philosophy. Philosophy is what really thinks things through and develops frameworks and paradigms of metaphysical questions and philosophical questions. But this is a central tenet of neuroscience. This has been in neuroscience and psychological science for decades. It's called Mueller's Doctrine of Specific Nerve Energy, M-U-L-L-E-R. You can look that up. Mueller's Doctrine. And Mueller's Doctrine states that, I got it right here. We directly perceive the activity of our nerves rather than the properties of the external world. And that was formulated back in 1835. So we've known this since 1835. I mean, there have been philosophical arguments, not quite that this is your brain rather than, well, we've known that this isn't the external world. These are just perceptions. That goes back to Berkeley, even back to Plato, the allegory of the cave. But focusing on that, this is your brain. Yeah, we've known that since 1835. It kind of relates to the concept of transduction, where there's this energy in the physical world, a stimuli energy. It could be light, sound waves, mechanical pressure, anything, chemicals, taste. And that physical energy gets transduced, we say, into what they call the language of the nervous system, which is action potentials. Fancy word for neurons firing. They also call it neural oscillations or neural impulses. Neurons firing, basically. So these patterns of neurons firing in a certain way codes the stimuli. So the light wavelength is the physical stimuli. Hits your eye, gets transduced eventually by the receptor cells into neural impulses. So that's transduction, that's the Mueller's doctrine of nerve energies. And equally relevant here is the law of projection, as it's called, which is anywhere you stimulate in a sensory pathway, the experience will end up being experienced as out there in the world. So you could stimulate the visual cortex, and in a certain way, people will say, oh yeah, I see something out there. Because that's what the brain's designed to do, create sensory representations of the world, create a simulation of the world. That's perceptual theory. You could also simulate the optic nerve. Simulate the nerve in a certain way. If you knew how to do it, you could make them see something that way. Or you just simulate the retina itself. You don't really need to have light hitting it. You close your eyes and just send electrical patterns right to the retina. Still, you're going to see it as out there in the world. That's why it's called the law of projection. So, yeah, you are looking at your brain. And the law of projection makes you see it as if it was out there in this world. But it's really all just sensory representations. That's perception. So this basic principle of neuroscience, it can't be overlooked. It can't be dismissed. If you think it through, then this is your brain. And I think that's pretty interesting. I don't know why we're not told that more exactly. I think, neuroscientists either they're not aware of this, or if they are aware of this, they explain it in such a technical way that the real meaning of the claim gets lost in translation. I mean, what it boils down to is that this is your brain. You can talk about stimuli and transducing cells, sensory receptors, and neural impulses. And that's great. That's very precise language, but this is your brain, is what they're saying. I don't know, maybe some neuroscientists just don't want to freak people out. And that's why they don't tell them. I don't know, because this is not something that's really spoken of. That's why I call it the untold truth of neuroscience. But I think we should take this seriously. If you deny it, you're just denying science. So this is as probable as science itself. It's not even really a scientific theory. It's just a technologically made possible observation of the brain. And then philosophy says, well, the simplest thing to say is that just is your brain, instead of, dualism. Oh, the brain generates this other realm of the mental. You could say that there's no evidence for that. There's no logical grounds for that. Even if energy could disappear from your brain and then reappear later, even if that didn't violate the laws of physics, we have no evidence for that. Why would we believe that? So it's just simple. It's like, kind of an Occam's razor type situation. Just, this is your brain, it makes sense to me. That's how hallucinations happen. That's how dreams happen. It's just that the brain can simulate these sensory representations. It's that simple. So there you have it. That's about it. I'm going to try and be as concise as possible here. Hopefully, this will put an end to there's a lot of confusions I've noticed in philosophy of mind that kind of have this as the basis. Questions like, well, what is an after image? If there's no green thing in your environment, yet you're seeing a green thing, are you seeing something immaterial? And that's an actual argument in philosophy of mind. And I think it's ridiculous. You're just seeing your brain. It's an after image. It's an effect of the opponent processing cells in your visual processing system. So, it's pretty baffling. You don't have to lose your head about it, though. It's how the world's always been. Everything's been like this forever. Everyone's just looking at their brain. They might not realize it. That's something that's different. This is now Picasso spent all day looking at his brain. Shakespeare saw nothing but neurons firing. Washington, he was just looking at his brain too. Visual experience is the only thing we know of. Vision. I said that weird. Vision is just visual experience, which is mental. It's phenomenal. And if we've identified the mind with the brain, then it's that simple. What do you think the visual cortex does? It's this. You're looking at it. So everyone throughout history has been looking at their brain, And I think it's about time we kind of acknowledge that, because I think it's pretty interesting, It definitely makes the hard problem of consciousness more interesting, because you're looking at it. You're looking at the hard problem. So, yeah, that's about it. I think knowing this can only make things better. We get closer to truth, right? That's the whole point of philosophy. Mysticism is the search for truth. That's science too, obviously. So I appreciate your open-mindedness, and I think we're a little better off for knowing. So, that external world you're seeing might be more intimate and subjective than you may have thought. So I mean this literally when I tell you, it's all in your head. Thank you.